Alright, we're going to do intervals of increasing, decreasing, now using a sign chart. So I introduced this idea a couple days ago, and some of you guys are still kind of figuring out what exactly I'm doing. So my first step is I need to find the critical numbers. Okay, and then we do that by setting our derivative equal to 0, or finding where our derivative doesn't exist. The next thing we're going to do is we're going to set up test intervals on a number line. So we're going to create a number line and then write our critical numbers on those number lines. We're going to find the sign of f prime, the derivative for each interval. If f prime is positive, then the function is increasing. If f prime is negative, then the function is decreasing. Alright, number 1, find the intervals on which the function f of x to the third minus 3x or 3 over 2x squared is increasing and decreasing, and justify. Alright, so the first thing we're going to do is we're going to take our derivative. So f prime of x is equal to 3x squared minus 3x. And we're going to set that equal to 0. I'm going to factor out a 3x, that's my greatest common factor. This leaves me with an x minus, and then 3x factored out with a 3x is 1. Please don't put 0 there. So I have 3x is equal to 0, that's one of my factors. My other factor is x minus 1 is equal to 0. If I divide both sides by 3, I get x is equal to 0, and then add 1 to both sides, and I'll get x is equal to 1. So these are my critical numbers. This is what I'm going to put on my number line. So let's set up my number line. So I have a critical number of 0, right there, and a critical number of 1. And I'm going to list my factors. And my factors are these guys. When I factored, I get this linear function times this linear function. You could have used this guy, but I think it's a little bit much to try to keep all the numbers straight in your head. So that's why I break it down into factors, and I'm going to list them. So we have our factors over here. We're going to write 3x, and then x minus 1. And so this is, we're going to be tracking on top f prime. On the bottom, we're tracking our x coordinates. So what I mean by that is, if I pick an x value right here, it's going to be negative. I could pick any one. So any number to the left of 0, it's going to be negative. So I'm going to say negative 1. That's a pretty easy one to pick. And so negative 1, so I'm going to plug that in here. So 3 times negative 1, I don't really care about the value, I care about the sign, because that's what we're tracking. So it would give me a negative 3, and that's a negative number. I'm going to plug in the same negative 1 into this factor. And negative 1 minus 1 gives me negative 2. And again, that's a negative number. Now I'm going to come over here and pick a number between 0 and 1. I'm going to say 0.5. And so I'm going to plug in 0.5 into this factor right here. Well, 3 times 0.5 is going to give me 1.5, which still is, it's a positive number. I'm going to plug in 0.5 here. Again, we're talking about a value between 0 and 1, so I'm going to say 0.5. Well, 0.5 minus 1 gives me negative 0.5. That's a negative number. Now I'm going to look for a value on my number line that's greater than 1. To the right of 1, I'm going to say 2. So 3 times 2 gives me a positive number. And then I'm going to come down to my other factor. 2 minus 1 gives me a positive number. And so since these are factors being multiplied, over here, notice how they're being multiplied? So that's where we're going to multiply our signs. So I have a negative answer times another negative answer. Well, a negative times a negative is a positive. A negative times a positive, well, that gives me a negative. A positive times a positive is a positive. And so now let's interpret our sign chart. If we're talking where f prime, here's my f prime. If f prime is positive, that means my f is increasing. So I'm going to draw a little picture here. That means f is increasing, the blue. If f prime is negative, that means my slopes are negative. If my slopes are negative, that means my function is decreasing. If my slopes are positive, that means my function is increasing. So in blue, I have a basic sketch of what my function will look like. Well, it's a cubic, so it's good that it looks like a cubic. So if I'm talking about f is increasing, from negative infinity to 0, and from 1 to infinity, because f prime is positive. F is decreasing from 0 to 1 because f prime is negative. Alright, number 2, let f be a function given by f of x is x to the fourth plus x squared minus 2, in which interval is f increasing, and justify. So again, let's go ahead and take our derivative. Try to go quickly on this one. This before x to the third plus 2x. I'm going to set that equal to 0. And my greatest common factor is 2x. So that leaves me with x squared, 2x squared, plus 1. And this is not factorable. I'm going to get non-real answers. So my only critical value is this guy right here. So I have 2x is equal to 0, x is equal to 0. So let's go ahead and quickly create our number line. And so here's my 0, here's my f prime, these are my x's. I'm still going to list my factors. I have a 2x, my factors over here. My 2x squared plus 1, and then my 2x. And so I'm going to pick values, so left of 0, I'm going to say negative 1. So if I plug in negative 1 into my first factor, I'm going to get a positive answer because I'm squaring a negative, and then multiplied by 2 and still adding 1. So I'm still going to get a positive answer. If I plug in negative 1 down here, I'm going to get negative 2, which gives me a negative answer. Alright, now I'm going to pick a number to the right of 0. Let's say 1. Well, if either way, for the first one, I'm still going to get a positive answer. And if I plug in 1 in the bottom, 2 times 1 is 2, it gives me a positive answer. And so now I can do a negative times a positive, gives me a negative. A positive times a positive gives me a positive. So my function is increasing, so is increasing only from 0 to infinity. So f is increasing from 0 to infinity because f prime is positive. Alright, number 3, find all the values where x of the function defined by f of x squared minus 3, quantity times e to the negative x, is increasing. So let's go ahead and take our derivative. We have to use the product rule because I have a quadratic times a exponential. So derivative of the first is 2x times the second added to the first times the derivative of the second. Make sure you take the derivative of your exponent. And so if I rewrite this, set equal to 0, I'm going to rewrite this. So I have 2x e to the negative x. And I'm going to move this negative 1. Sorry, guys. Sorry, I have no idea what happened there. I'm going to move this negative 1 here. I'm going to make this negative because we're multiplying a negative and a positive. So I have x squared minus 3 times e to the negative x. And so in terms of factoring, I want you to know your greatest common factor right now is this e to the negative x. So let's factor that out. That means 2x minus x squared minus 3. Please keep that in parentheses so you remember to distribute your negative. So I have 2x minus x squared plus 3. And I don't like working with a negative x squared, so I'm going to factor out a negative from this quantity right here. So this becomes negative e to the negative x. And then I'm going to go ahead and put this in order. So instead of negative x squared, I'm going to positive x squared. Instead of positive 2x, I'm going to have negative 2x. Instead of positive 3, I have negative 3. And in terms of factoring, we're just going to factor our quadratic. And so this will be x minus 3x plus 1. So just so you know, e to the x never crosses the x-axis. And so that value is never 0. So we're not even going to worry about it. So we get x-intercepts at x is equal to 3 and x is equal to negative 1. And so when we create our number line, we're going to talk about negative 1, and we're going to talk about 3. But we're going to list all of our factors. So we have negative e to the negative x. We have x minus 3. And we have x plus 1. And so if I plug in a value over here, let's say negative 2, e is always going to be negative. And so this is always going to give me a negative answer. If I plug in negative 2 into x minus 3, I'm still going to get a negative number. If I plug in negative 2 plus 1, it's still going to give me a negative number. That's going to be, so negative times a negative times a negative gives me a negative. If I plug in 0, I'm still going to get a negative number. If I plug in 0, I'm going to get another negative number. If I plug in 0, I'm finally getting a positive number. So a negative times a negative is a positive times a positive is a positive. And so finally, I'm going to plug in a number over here, let's say 4. That's still going to give me a negative number because of the negative out here. And then 4 minus 3 is positive, 4 plus 1 is positive, that gives me a negative. And so the only place where it's increasing is where my f prime is positive. So f is increasing from negative 1 to 3 because f prime is positive.